Hello, Professor.
So, today we are on physics lecture number 18, projectile motion. So, we're going to be talking about the lesson's self-explanatory projectile motion. So, let me grab a red marker from here. And let's begin with our do now. So a ball slips off a table. Draw V, Vx, and Vy. So V really is the resultant. But first, let's draw some
Why are you
points.
blocking?
Let's draw some points on our graph.
Professor, please don't block.
I'm not
You know
blocking.
I'm half blind.
I'm blocking.
Okay.
And then,
Is that a ball?
no. These are 5 points in which this green ball falls from the table. Now, I'm going to draw the X in an orange color and Vy using mauve color.
Professor, what does V mean?
V means the resultant, the middle of Vx and Vy. So let me
So
put,
it means velocity?
yeah, really means total velocity. Just like we discussed in the river problem. So let's do Vx. Vx here. And
Professor, don't block what you write.
here, Vy is 0. Wow, these markers are really good.
Professor, don't block what you write.
I'm not blocking.
Okay.
Yes. And then Vy gains a little magnitude downwards. Because of gravity, Vy keeps accelerating.
Okay.
So it keeps gaining. And then, the moment, this is the moment before it hits the ground. So,
Professor, don't block what you write.
hey, I'm not blocking. You're just blind.
I guess that's the reason.
And then, Vx is still the same. So Vx never changes, but Vy always changes due to gravity.
Hey, Professor, Vx is always the same?
Yes. Didn't you know? We did this earlier, like lecture 6.
I don't even remember what we did yesterday.
Go get a bigger hippocampus, Mr. Calienda.
Why VX is
Huh?
Why is Vx constant? I think that's what he's trying to say.
Oh, Vx is constant because gravity points down. Has nothing to do with the x direction.
Oh, that's why Vy is increasing.
Or increasing downward. Now, you might have realized that I said draw V, Vx, Vy.
I did realize that.
Yeah, so we have to draw the resultant of the two, the middle. We are going to represent that using red. Surprising how I've never used black, huh?
Professor, please don't block what
And
you
you
write.
can see the resultant is pointing toward the downward because of Vy. So that's how we do now.
Can we go home now?
Oh my goodness. You lazy Albert. We have to keep moving. This is do now. We're only at the lesson. Now I'm going to start to use black. Okay. Now for our lesson, we're going to talk about a problem that obviously involves projectile motion.
Professor, what is that?
That's a cliff, and you're standing near the edge, which is probably a very bad idea. The cliff is 100 meters high. Now, you wanting to be safe from danger, throw a rock up in the air, and the rock lands 90 meters from where you threw it.
Oh.
So,
Professor,
this
don't
little,
block what you write.
I'm not blocking.
Just stand to the side, please.
So this whole thing is 90 meters. Now,
Where is the path of the ball?
the
yeah.
path of the ball.
How does the ball fall?
So the
Like,
ball just falls like a projectile, like you saw in the do not. I'm going to drop this in here and draw the path in red instead.
I think it will look like just a line. But maybe I'm wrong.
It looks just like it did in the do now.
Is that a parabola?
Yes. All things fall in a parabola once you throw them. Because if you throw them, they also have an X component, which will slightly tilt the line and make it become a parabola by bending it.
Oh, it kind of bends the line.
Okay. Draw. Oh, no. That's... Okay, so, what I'm going to want you to find is the VX. What is VX when you threw it initially?
I have an idea, Professor.
You should write it on the top.
Oh, yeah. What is VX initially when you threw... What is VX initially when you threw the ball?
V, Vy is 0. Vy is 0.
I know Vy is 0 here, but we are trying to find Vx.
Vy is 0. Vy is 0.
No,
Vy is 0.
Alex, you don't understand.
Oh,
We're trying
I
to
get
find
it.
Vx.
Vy is 0.
Yeah.
Vy is 0. Vy is 0.
Why did I let you two into my class? Now, let's find Vx. First, we're going to use this equation. Y equals to y initial. Y really means distance in the y-axis. Plus Vy initial t plus half a t squared, a yt squared. So y is 100.
Y0 is 0.
Yeah, y0, that means initial, don't get confused with 0. Plus vy initial is always 0. So vyot would be set to 0. And half a y is 9.8. So half a y would just be 4.9 t squared.
Oh.
So
Do you want me to calculate, Professor? I have my calculator.
4.517.
Hours, years,
That's
light years.
wrong. T squared is 100. That's wrong.
Oh,
T squared
yeah.
is 100. That's wrong.
Oops.
T squared is 100. That's wrong.
No. Calm down now.
Professor,
What?
I believe that T is 4.17.
No, it's 4.517. Very different.
Years, light years,
Oh my,
centuries.
oh my goodness. Let's
Oh.
find the a reasonable unit of time. What's wrong with you, light years?
Go on, cows. Go on, cows. Go on, cows.
Yeah, you should go back to Kelvin. Honestly. Now, Vx. Yeah, Vx initial is equal to x over t. Vx would be 90 meters over t.
4.517 seconds.
So I believe that's
Allow me to count.
90.922. Yes.
How did you do it so fast?
MPH, MPH, MPH,
Oh my goodness.
Oh,
MPH,
No.
MPH, MPH.
Meters per second.
oh, I thought it was kilometers per hour, but okay.
My goodness. You people are crazy.
Where are you from? Where are you from?
You shouldn't ask me there.
Should ask him that, and you should ask yourself that. You're honestly failing. You're both honestly failing this class. Anyways, I'm going to a race to do now to make way for the exit slip.
Oh, Professor, I
What?
thought we were gonna go home now.
What?
You promised me.
When did I ever promise you? Albert, you impatient freak. If you want to, go plant a tree in your home, then hug your home, then hug a tree. Because I know you have a love for both of those. Goodness gracious. This guy. Good patient. At least Alex isn't asking for that. Should be more mature, Albert.
Sorry, Professor.
Sorry. Okay. Now you have another cliff. Probably an even worse idea to stand on this one, because it's 1.5 times as tall as the last one.
Wow.
But still, because you're dumb, you stand at the edge of the cliff.
Professor, don't block what you write, please.
And then you throw the rock head down. Somehow you manage to collect it from the ground of that cliff. Now let's draw the path.
Would the path look like a parabola?
Yes,
Wow.
precisely.
I learned something new today.
Learn something new? This was mentioned in like lecture 5 or 6.
And how far does it travel horizontally, Professor?
How far it travels horizontally? Oh, it travels only 75 meters. You were less enthusiastic about this one.
Oh,
After climbing down and getting the other one. We're less enthusiastic, we're tired. Now, we can use the same method to do this one. Use the same tricks.
are we gonna find the horizontal velocity, Professor?
Yeah, we can use our same trick to do this one.
Wait, Professor, how did you get 4.9 t squared?
The
I
same,
thought it was half a t squared.
the same thing is this. The same thing is this. Half 9.8 is, so 8 is 9.8. So 8 times 10 is 98. Half that you get 49. Then divide by 10 again, you get the point, 4.9.
My God, I would never have understood that.
150.
Okay, let me just calculate that, Professor. Can you give me some time?
Get a calculator. I'm not sure if you can calculate that yourself.
So 150 divided by 5, that's about 30. And then if I want to find the square root of
Just
30,
I'm just gonna do this alone because you
calculating,
guys won't do this for me. So I'm just gonna do it alone.
so square root of 30 is all you need to find, right?
Plus 150
150
over 4.
over 4.9,
150 over 4.
and then take the square root of that. You should take the principal square root.
Okay, what did you get?
I think I got about 4.6, but I'm not sure. I may be wrong. I got
Well,
about 5.1.
let's look. Let's see if you were right or wrong.
I got about
So,
5.1,
30
5.2.
square root. Yeah, 5.47.
Oh, I was close.
I was wrong. Anyways, that gave us so we actually
Is that in seconds, Professor?
yes, second. Meters second. So this would be in meters per second. Drum roll, please.
Wait,
Okay, that was pathetic.
75 meters over 5.47 seconds.
13.6.
Meters per second?
Yes.
Oh,
Thank you,
looks
Professor.
just like a tree diagram.
It's supposed to be 13.555. 555.
Thank you, Professor.
Thank you.
Bye, everybody.
Bye.